Here are the solutions to a sample test for the grade 12 Calculus and Vectors course. This is the second vectors test, which is on Cartesian or algebraic vectors. Question 1. Write vector AB in component form, draw it in standard position, and determine its magnitude. To write it in component form, I'm going to first have to label the coordinates of the tail and the tip of this vector. The tail is at -5, -3, and the tip is at -1, 4. Now when I write it in component form, I do the coordinates of the tip of the vector minus the coordinates of the tail of the vector. So for vector AB, its x component would be -1 minus -5, and its y component would be 4 minus -3, which means this would equal the x component of this vector, -1 plus 5 is 4, the y component, 4 minus -3 is 7. Now I need to draw this vector in standard position. That means translate it so its tail is at the origin, and I know if I translated it so its tail is at the origin, its tip would be at 4, 7. So let me plot a point at 4, 7, and let me draw a vector that goes from the origin to that point. And that is vector AB. I also need to find its magnitude. If I use Pythagorean's theorem to find its magnitude, I know that the magnitude of vector AB is equal to the square root of its x component squared plus its y component squared. So that would equal 16 plus 49 is 65. So it's just the square root of 65. Question 2 gives me 3 vectors, and it says to calculate the following if possible, and if not possible, explain why not. So for part A, I need to do 2 times vector D minus vector E. Well, that's possible to do. I can multiply a vector by a scalar, so I need to do 2 times vector D, which is -5, -2, 1. And then I need to subtract vector E, which is 3, 0, 2. Let me multiply the scalar into vector D first. That would be -10, -4, 2. And now I will subtract the vector 3, 0, 2. So I'll start by subtracting the x components. -10 minus 3 is -13. The y components, -4 minus 0 is -4. And the z components, 2 minus 2 is 0. So there's my result. Part B wants the magnitude of c plus 3e. Let me start by just rewriting c and e with their vectors. I will start by multiplying vector e by 3, which gives me 9, 0, 6. Now I'll add those two vectors together. I'll add the x components, -3 plus 9 is 6, add the y's, and add the z components, 5 plus 6 is 11. Now I need to find the magnitude of this vector, so I do the square root of the x component squared plus the y component squared plus the z component squared. So that would give me, I have 36 plus 16, that's 52, plus 121, that is 173. So the square root of 173. Next question. It asks me to find, this notation, d hat, that just means unit vector d. And unit vector d, I know I can create a unit vector in the direction of d by multiplying vector d by 1 over its magnitude. So 1 over the magnitude of d times d will create unit vector d. Well, what's the magnitude of vector d? Let me look up what is vector d. Vector d is -5, -2, 1. So if I want its magnitude, I do the square root of the sum of the squares of its components. So the square root of 25 plus 4 plus 1, that is 30. So I will do 1 over root 30 times vector d, which is -5, -2, 1. Now we could rationalize this and distribute that scalar into the vector, but I'll just leave it like that. C dot E. Well, dot product, let me replace C and E with what their equivalent vectors are. Okay, and now when I'm doing dot product with algebraic vectors, I multiply the x components, -3 times 3, plus multiply the y components, plus multiply the z components. If I add all those products together, I have -9 plus 0 plus 10, that is 1. There's the dot product. Part E asks me to do C dot D dot E. Well, I know this one's not going to be possible because when I do the first dot product, C dot D, that's going to give me a scalar. And then when I dot product that with E, well, E is a vector, And I can't do a scalar dot producted with a vector. Dot product is only between two vectors. So I'll say this one is not possible. And the reason being, we can't dot product a scalar with a vector. A scalar and a vector can be multiplied together, but not be dot producted or cross producted. F. Let me just replace all of those vectors with what they're equal to. All right, now I have to follow the correct order of operations here, so I'll evaluate inside of the brackets first. So I'm going to look at inside of here. My x component of that vector is going to be -3 plus 2 times -5. So -3 plus -10, that's -13. The y component I'm going to get by doing 4 plus 2 times -2. So 4 plus -4, that's 0. And the z component, I'll do 5 plus 2 times 1. So 5 plus 2 is 7. I need to dot product that with 3 minus -3, which is 6. 0 minus 4, which is -4. And 2 minus 5, which is -3. And now when I do the dot product, I will multiply the x components, plus multiply the y components, plus multiply the z components. This gives me -13 times 6 is -60 plus -18, that's -78, plus 0 plus -21. So -78 plus -21 is -99. G, this is our first cross product. If I'm doing cross product, I want to carefully, underneath vector C, write its components. But I'm going to write it in the order second, third, first, second. So I'm going to write 4, 5, -3, 4. And underneath D, same pattern. So it'll be -2, 1, -5, -2. And when I do cross product, I'm going to get a vector answer. To get the x component of the vector, I'm going to do 4 times 1 minus 5 times -2. So I've got 4 minus -10. That'll get me the x component. To get the y component, 5 times -5 minus -3 times 1. So -25 minus -3. And the z component I'll get by doing -3 times -2 minus 4 times -5. So that's 6 minus -20. Let me simplify this vector. It gives me 14, -22, 26. H says find the volume of the parallelepiped formed by the three vectors. Well, if I want the volume of the parallelepiped, I just find the absolute value of the triple scalar product. I might as well do C cross D dot E. And I chose it to do in that order because I already know what C cross D is equal to. And remember, when we do a triple scalar product, we always do cross product first and then dot product. C cross D, we have the answer. That is 14, -22, 26. I just need to dot product that with vector E, and let me remember what vector E was. It was 3, 0, 2. I will find the dot product by multiplying the x's, plus multiplying the y's, plus multiplying the z's. And this gives me 42 plus nothing plus 52, which is just 94, and the absolute value of 94 is 94. And because this is a volume, I should write units cubed. Part I asks me to find the projection of E onto D. This is a vector projection, so my answer is going to be a vector. And I can get that vector projection by doing the formula E dot D divided by D dot D multiplied by vector D. All right, when doing E dot D, I'll multiply the x's. -5 times 3 is -15. Plus multiply the y's. -2 times 0 is 0. Plus multiply the z's. 1 times 2 is 2. Over D dot D. Well, if we think about what that means, it just means multiply the x component of D by itself, plus multiply the y component by itself, plus the z by itself. So it would be negative 5 times negative 5, which is 25, plus negative 2 times negative 2, which is 4, plus 1 times 1, which is 1. All of this is being multiplied by vector d. If I simplify the fraction, I have negative 13 over 30 times negative 5, negative 2, 1. J says find the angle between C and D. Well, if I want the angle between two vectors, the best thing to do is rearrange the dot product formula. There's the dot product formula. Let's isolate cos theta by dividing the magnitudes of C and D. And then we can quickly calculate all of these things. Let me rewrite vector C and D up here so that we don't have to keep scrolling. All right, if I'm doing the dot product of C and D, I would have negative 3 times negative 5, plus 4 times negative 2, plus 5 times 1, all over the product of the magnitudes of C and D. Well, the magnitude of C, I'll just do negative 3 squared plus 4 squared plus 5 squared. That would be 9 plus 16 plus 25, that's 50. And that's being multiplied by the square root of negative 5 squared plus negative 2 squared plus 1 squared. 25 plus 4 plus 1 is 30. So this is what cos theta is equal to. If I want to actually calculate theta, I'll just evaluate this entire ratio and then do inverse cos of it. Maybe I should simplify it a bit. First, I've got in the numerator 12. In the denominator, I have the square root of 1500. I can finish this over here. Theta is equal to inverse cos of this ratio, and I'll use my calculator for that, and I get 71.95 degrees. And part K is the last part of this question. I need to find a vector, and it's telling me to call it vector f, that's perpendicular to both D and E. Well, if I want a vector perpendicular to two other vectors, I just find their cross product. So I can say vector f is equal to vector D cross vector E. When I'm doing the cross product, underneath D, I'll write its second component, third component, first, second, same thing under E. So 0, 2, 3, 0. The cross product is going to give me a vector, and the important thing is that that vector is perpendicular to both D and E. So I'll get the x component by doing the product of those two, negative 4, minus the product of those two. So negative 4 minus 0. For y, I will get 3 minus negative 10. And for z, I will get 0 minus negative 6. That gives me the vector negative 4, 13, 6. I could check the dot product of that vector with vector D and vector E, and both dot products would be 0, verifying that it is in fact perpendicular to both. Question 3 says, given vector A and B, determine the value of x, and notice x is the missing component of vector B, so that A and B are collinear. If A and B are collinear, then they would be scalar multiples of each other. So there should be some scalar k that I can multiply vector B by to make it equal to vector A. So that would mean that 7, 2 equals k times x negative 6. Now let me split this into its x and y components. So 7 would equal kx, and 2 would equal negative 6 times k. Let me solve for k with the y components by dividing the negative 6, and I get k equals negative 1/3. I will then sub that k equals negative 1/3 in for k into the equation I made from the x components and solve for x. So 7 equals negative 1/3 times x. If I multiply both sides by 3, I've got 21 equals negative x, which means x is equal to negative 21. Part B says determine a value of x so that A and B are perpendicular. Well, A and B would be perpendicular if their dot product was 0. So I will set A dot B equal to 0 and then solve for x. So vector A is 7, 2. Vector B is x negative 6. And their dot product is 0. So dot product, I multiply the x components, so 7 times x, plus multiply the y components. And now I just isolate for x. So I have 7x equals 12 divide the 7 over. I have x equals 12 over 7. Question 4. It says, given the diagrams, this time I'm given geometric vectors, calculate g dot h. Well, the formula for dot product with geometric vectors, it's equal to the magnitude of g times the magnitude of h times cosine of the angle between them. So in this question, it would be 7 times 10 times cosine of 130 degrees. And that gives me about negative 45. Part B says calculate the projection of h onto g. If I want to project h onto g, my formula for that would be equal to the magnitude of h times cosine of the angle times unit vector g. If I sub in what I know here, magnitude of h is 7, the angle is 130, and I just leave unit vector g written like that. And this gives me about negative 4.5 g hat. That means a vector that is going in the opposite direction of g and has a length of 4.5. And that's what the projection would look like. If I skip ahead to part D right now, it says draw that projection of h onto g. If I'm projecting h onto g, I know that the projection is going to go parallel to g, either in the same direction if the angle is less than 90, or in the opposite direction if the angle between them is greater than 90. So in this one, it's in the opposite direction. And it goes to a point so that if I were to connect this vector back up to the tip of h, there would be a 90-degree angle with that new line I drew and the projection vector. And on that projection vector, I should make sure I clearly indicate that it is going in this direction, and let me label it as this is the projection of vector h onto vector g. And that vector, I guess, has a length of 4.5 based on what I found in part B. Part C says calculate h cross g. If I want to do a cross product, geometric vectors, the formula is I multiply their magnitudes times sine of the angle between them. But then also, I need to send this in a direction perpendicular to both of them. So I'll multiply it by a normal vector, which has a length of 1. So n hat is the unit normal vector. If I sub in what I know, I have 7 times 10 times sine of 130. And for h cross g, if I use the right hand rule, if I were to lay my right hand along h and curl my fingers towards g, my thumb will be pointing into the page. So for this one, I'm going to have to make my n hat negative. So negative n hat, because it's going into the page. If I multiply this out, I would get negative 53.6 n hat. I could say that, or I could say 53.6 into the page. Both of those communicate the same thing. All right, almost done. Question 5. I've got 3 points that form a triangle. I want to classify the type of triangle as either scalene, isosceles, or equilateral, and I need to show my work. So I'm going to have to find the magnitude of the 3 sides that form this triangle. It might help if I just do a rough sketch of this triangle. Now, this triangle is not in the right orientation by any means, but I just wanted to have a diagram so I could visualize what vectors I'm going to be finding. Let's find vector AB, AC, and BC. And when I'm finding any of those vectors, I do the coordinates of the tip minus the coordinates of the tail. So for AB, I do the coordinates from point B minus the coordinates from point A. So let me find that first. Vector AB would equal negative 2 minus 3 is negative 5, 0 minus negative 2, and 5 minus 4. There's AB, and I might want to actually find the magnitude of that vector by doing the square root of the sum of the squares of the components. So negative 5 squared plus 2 squared plus 1 squared is 30. How about AC? Vector AC, I'll do the coordinates of the point at the tip minus the tail. That would give me 0, negative 3, negative 8. If I find that vector's magnitude, I would get the square root of 0 plus 9 plus 64, that's the square root of 73. And my last vector, BC, coordinates of the tip minus coordinates of the tail, that would give me 5, -5, -9. If I find that vector's magnitude, it would be the square root of 25 plus 25 plus 81. So 50 plus 81 is 131. Because all three side lengths that I have found here are all different, I know that this is a scalene triangle. Part B says, does the triangle have a right angle? Give proof. Well, if it had a right angle, I know Pythagorean theorem would hold true. So if it had a right angle, I know that the sum of the squares of the shorter two sides, so the magnitude of AB squared plus the magnitude of AC squared, would be equal to the square of the magnitude of the longest side, which is BC squared. If I replace these with their magnitudes, I get root 30 squared plus root 73 squared equals root 131 squared. A square root and a square are inverse operations, so they cancel out. So I've got 30 plus 73 equals 131, which gives me 103 is equal to 131. Well, I can tell that those are not equal, which means it is not a right triangle. Part C says find the area of the triangle. Well, I know a triangle is half a parallelogram, and the magnitude of cross product finds me the area of a parallelogram, so I'll cut the magnitude of the cross product in half, and that gives me the area of the triangle. Now I have to make sure when I'm doing the cross product to do this, I have to pick two vectors that are tail to tail with each other. That's how they have to be oriented to do cross product. So I will use vectors AB and AC because they are tail to tail. So I'll say the area equals the magnitude of AB cross AC. So that would equal the magnitude of, and now I need to find the cross product of those two vectors. So those two vectors, what were they? AB was -5, 2, 1. So underneath AB, I will write 2, 1, -5, 2. And AC was 0, -3, -8. So I will write -3, -8, 0, -3. Oh, and remember, I almost forgot, I'm going to have to be cutting this area in half, right? So the area would equal a half of this magnitude. So let me put a half in front of there. And now when I find the cross product, I've got -16 minus -3. I've got 0 minus 40. And I have 15 minus 0. So this would equal a half times the magnitude of vector -13, -40, 15. And that's equal to a half multiplied by, if I find its magnitude, I get the square root of 1994. And I can just leave my final answer like that. It's an area, so I should write units squared. The next question is a work question, and work is a dot product application. We can calculate work by doing force dot displacement. So let me draw a diagram that models the situation here. It says a golf cart is pulled 100 meters up a hill under a constant force of 30 newtons applied at 70 degrees to a horizontal. So it describes the force and the displacement. And then the next sentence says the hill is inclined at an angle of 30 degrees. So let me start by drawing a hill that is inclined at 30 degrees. So there's my hill that's inclined at 30 degrees. And I know that the force that is used to pull it up the hill makes a 70-degree angle with a horizontal. So the force, which is this vector right here, makes a 70-degree angle with a horizontal. Well, the hill is inclined at 30 degrees. So that means the angle between the force and the hill is going to have to be 40 degrees so that that maintains that 70-degree angle with a horizontal. I know the displacement is going to go in the direction of the hill, so my displacement vector is going to be going on the hill. It's being pulled up the hill. And I know the magnitudes of both of those, so I can go ahead and do my dot product now. So it would be the magnitude of the force times the magnitude of the displacement times cosine of the angle between them, which in this question, the magnitude of the force is 30 newtons, the displacement is 100 meters, and the angle between them is 40 degrees. And that gives me 2,298.13 Newton meters, or we could write joules. Question 7 is a torque question. It says a 40 Newton force is applied at the end of a 20 centimeter wrench. When I'm doing torque, I know I'm going to have my length of the torque arm in meters, so I'm going to change that to 0.2 meters. If the force makes an angle of 50 degrees with the wrench, what is the magnitude of the torque about the point of rotation? Include a diagram. So I'm just going to make a rough sketch. I've got my bolt that's being tightened by the wrench, and I know there's going to be a vector along the wrench that points away from the axis of rotation. So this we call vector r. We can think of that being along the direction of the wrench. And it tells me there is a force being applied to the wrench at an angle of 50 degrees with the wrench. So there is some force that is being applied to the wrench, and it makes an angle of 50 degrees with the wrench. Now I know torque. I can find the magnitude of the torque. So the magnitude of the torque is equal to the magnitude of r cross f. I'm not interested in the direction for this question, so when I do the cross product with the geometric vectors, I just have to do the magnitude of r times the magnitude of f times sine of the angle between them. And I don't need to include the n hat because I'm just getting the magnitude, not the direction for this one. So if I sub in what I know, the magnitude of r is 0.2. The magnitude of the force is 40 newtons. Times sine of the angle between the vectors. Now, I should use the angle when they're tail to tail. When doing cross product, they have to be tail to tail. So I should redraw the force vector so that it has its tail at the tail of vector r. So let me redraw vector f right here. I tried to keep its magnitude and direction the same. You should notice these two vectors are the same and they're connected by that line. So the angles inside of a z pattern are equal, which means that this angle right here is also 50 degrees. So when I'm doing my cross product calculation, I can use that 50-degree angle. So this gives us about 6.13 Newton meters. I'll write it in joules. And almost at the end of the test, number 8 says, when finding a dot product of two vectors, what are you finding the product of? Be specific and include a diagram. So if I'm doing A dot B, let's say, well, let me draw a vector A and a vector B. If I'm finding the dot product of those two vectors, what I'm finding the product of is two things. I'm finding the product of the magnitude of one of those two vectors. We could pick either one. I'll just pick vector A. And that gets multiplied by the magnitude of the projection of the other vector, so vector B, onto the first vector, vector A. So let me write that in words. It is the product of the magnitude of one vector, I chose A, times the magnitude of the projection of the second vector onto the first vector. So in this case, that would be the magnitude of the projection of B onto A. And let me show you in the diagram what that looks like. What does the projection of B onto A actually look like? Well, if I'm projecting vector B onto vector A, I know it's going to go parallel to A, and it's going to go until a point, so that if I were to stop and connect the tip of it back up to the tip of vector B, it would form a 90-degree angle. So I need to indicate the direction of this is this way, and let me label what that blue vector is. That is the projection of B onto A. So if I found the magnitude of all of A and multiplied that by the magnitude of the projection of B onto A, that is what the dot product is. So question 9 wants me to draw this three-dimensional vector and then determine its magnitude. It's the vector 5, negative 3, 6. So I need to move 5 in the positive x direction. And then after moving 5 in the positive x direction, I need to move 3 in the negative y direction. The green one is the y-axis. So I need to move 3 in the negative y direction. And I'm going to move that's 3 in the negative y direction, to where I left off after I moved 5 in the positive x direction. And then lastly, I need to move 6 in the positive z direction. And I need to do that from where I left off after moving in the y direction. So from there. So the vector is going to go from the origin to where that blue vector last left off. So this purple vector right here is going to be vector A. So let me label it. I need to find that vector's magnitude. In 3 dimensions, I just do the square root of its components squared. So I've got the square root of 25 plus 9, that's 34, plus 36, 34 plus 36 is 70. So I just have the square root of 70 as its magnitude. If you want some extra fun, maybe you could figure out how in questions 6 and 7 you can maximize work and torque by adjusting how the force is applied. Jensen Math!